Hello everyone, welcome to the next video, and like I said, we are going to be covering log in this video, but also just basic algebraic manipulation because you guys should sort of be masters of algebra before going into physics. Like the math shouldn't be the problem, if you know what I mean. So let's say you're sort of faced with, I don't know, ax squared plus bx plus c equals 0. You already know quadratic formula. Okay, quadratic formula, please. Now, we did go over in the other video some trig manipulations, and now I'm going to go over log. So the way log works is, okay, let's say we had 2 to the power of x is equal to 4, right? Now, I think most people can see here that x is equal to 2, right? Because 2 to the power of 2 is equal to 4. Nice. But, okay, wait, let's say I had x squared equal to 4, right? So the inverse operation would be to take the square root on both sides. So this would cancel out, and we'd get x equal to plus or minus root 4, which is just plus or minus 2. So we need a new inverse function for when it's in the exponent. So another way I want you to think about this, though, is x squared. And what we're doing is we're actually raising both sides to the exponent of half. You can see then that using exponent laws, this is just 2 times 1 over 2, right? Which is just x to the power of 1, which is just x. And instead of using roots, use fractions, because you're going to get problems like this, right? And I don't know, writing it like this it's kind of confusing. So this notation is better. Plus, all you need to do is now exponentiate both sides to 3 over 2. And these will cancel out, and you'll see x is equal to 4 to the 3 over 2, which is just the same thing as 8. Okay? Also negative 8. But anyway, now that we're here, the inverse function is called log. So log has two components. It has a base, and then it has its actual input over here. In this case, I want to use log base 2 because my base is 2. And you'll see why in a moment. So I'm taking log base 2 on both sides. This is like all operations, you have to do it on both sides. You can't just do it on one, right? So here's a couple properties of logs. So just how exponents have like laws that you learn, logarithms have laws as well. So the first one I'm going to go over is log base a of b to the power of x. So a and b are just some number. Same thing with x, actually. I'm going to say this is equivalent to x times log base a of b. So basically, when you have log, you're allowed to take this thing out and put it in the front. And you can look into why it's true, but I'm not going to prove it. We're just going to use that fact for now. So I'm going to take this x out. So x times log base 2 of 2 is equal to, and this you're going to put in your calculator. Okay? Okay, this one you can do in your head, right? But normally, like if this was 5, you can't do that in your head. So that's why you would use a calculator, or you could just leave it like log base 2 of 5. That's fine too. But anyway, if you put that in your calculator, you'll get 2. And another useful property is log base a of a is equal to 1. Now there are restrictions. For example, a cannot equal 0 or 1. And normally a cannot equal a negative number either. However, I don't want to lie to you guys. So in the future, you will learn how to take negative logs. But in physics, you don't need to. So we don't worry about that for now. But essentially, we have log base 2 of 2. And we know that like log base 3 of 3 or log base 100 of 100, like these are all equal to 1. Okay. So This is just 1. We get x equals 2. So that's how you would algebraically solve this equation. Why is this helpful? Well, because you might get an even more complicated equation. For example, 2 times 3 to the power of x plus 2 is equal to 5 times 7, I don't know, x, 3x. Okay, let's say that, or plus 1. Let's say that this was what you got. So in order to solve this, we're going to take log on both sides. Now, if you guys don't know what the number e is like approximately equal to 2.7 blah blah blah. It's kind of like pi. It's an irrational number. I like taking log base e, always log base e. Like the reason we took log base 2 here is because there's only one thing, right? Only one base, and it's 2. In this case, we have 3 and 7. So taking either log base 3 or log base 7, it's not going to help. There's no point. Log base e can be written as ln, or ln, you might see people pronounce it as. So if you ever heard of ln or ln, that's where it comes from. Anyways, I'm going to take ln on both sides. By the way, if you see just log written without a base, it's implied the base is 10. Some people find that 10 is a helpful base. I don't. I prefer ln, and I think you guys will too, especially for physics. I would use ln. But here, we're going to use another useful property of log, which is that log base a of, I don't know, n times m is equal to log base a of n plus log base a of m. This right here. In other words, we're going to have ln 2 plus ln of 3x plus 2 is equal to ln 5 plus ln of 7 3x plus 1. By the way, if you have just one thing, you don't really have to write the brackets. This is just sort of implied that it's ln 5. Okay. Anyway, now this is just a constant. Just remind yourself that, okay? ln 5 is just some number. It's some irrational number, but who cares? Let's bring it to the other side. So, or let's just bring all the constants to this side and all the x's to this side. Okay? So we'll have ln of 3x plus 2 minus ln of 7 3x plus 1 is equal to ln 5 minus ln 2. So, remember how I said plus is multiplication? Well, log base a of n over m is equal to log base a of n minus log base a of m. So this part can actually be rewritten as ln of 5 over 2. I hope that wasn't too fast. Subtraction turns into division. Addition turns into multiplication. The reason is because with exponentials, it's the opposite. Like if I had 2 to the power of 2 times 2 to the power of 5, that's equal to 2 to the power of 2 plus 5 is equal to 2 to the 7, right? So log is just the opposite, really. But anyway, we're going to use our taking out one. Remember our taking out one. So x plus 2 multiplied by ln 3 minus 3x plus 1 times ln 7. Now let's expand this. We'll get x ln 3 minus 3x ln 7. And then I'm just going to bring the rest of these things to the other side. So we'll have ln 5 over 2 plus ln 7 minus 2 ln 3. I hope that I did that correctly. I think I did. Yeah. Okay, now we can factor out x. So then, sorry. If I factor out x, we'll get ln 3 minus 3 ln 7 is equal to, now we gotta put this guy back in here, right? So that'll become ln 9. So then we'll have ln 35, because I'm multiplying 5 and 7, and then I'm multiplying 9 and 2, which would give me 18. Next, we can just divide both sides by this monstrosity over here, and we'll get ln 35 over 18 divided by ln 3 minus 3 ln 7. Now, this could definitely be your final answer. I don't see any problem with that. But we're going to do some cool things because I want to show off the last and arguably the most important log law, at least for me. Actually, that's just 343. I can't do the quick math. We're going to just leave it like that. But if we have log base A of B, this is equal to log base C of B over log base C of A. C can be anything. C can be anything. As long as the top and the bottom are the same, it can be anything. For example, log base 2 of 4, which we said was 2, I can say this is log base 3 of 4 divided by log base 3 of 2. And we know that that's just equal to 2. That's pretty cool, isn't it? This random thing is equal to 2. I find that pretty cool. Anyway, so we can rewrite this as log base 3 times 343 of 35 over 18. And that is also, well, I mean, normally you just put that in your calculator, but like, you get the point. This is an acceptable final answer. Sorry, this should say 18. This problem over here is probably what you're gonna get as a log problem. It's probably the hardest it's gonna get. There are harder problems, but like in physics you don't really encounter them. So as long as you know the general method of sort of, expanding, bringing all constants to one side, expanding again over here, and then bringing all the constants to the other side again over here, and then finally dividing both sides by this after you factor out x, and then you can simplify, but it doesn't matter. Just put this in your calculator, write it to 2 decimal places, and it's the same thing. Okay. In fact, most calculators don't even have log base, which is why change of base is so important to know, because this is what your calculator is going to accept, not that. I know I showed it in the inverse, but like, I just wanted to show it off. Anyway, those are all the log laws, and we did go over some basic algebraic manipulation as well, right, with the quadratic formula. And you know what, actually I'm going to go over some more algebraic manipulation. So for example, if we have like 3x plus 6 equals, I don't know, 4x plus 7. Guys, it should be instantaneous at this point. Bring that to that side, bring that to that side. -1 is equal to x. Boom. Done. Done. Okay. Should be instantaneous at this point. Yeah, so addition and subtraction are inverses. Multiplication and division are inverses. Although I want to get rid of division and focus more on fractions. So like 2 times 1 over 2 as opposed to 2 divided by 2. We don't want this. This is what we want. And then the final thing would be exponents and log. Okay, so again I'm using E. E is the most common base. You're going to see it all the time. It has magical properties. When you get into derivatives and integrals, it's much easier to use that base. So I suggest getting used to it now as opposed to doing 10 to the x / log x, right? I don't really like that. It's harder. Just stick to this, please. And then the last one would be sine x slash arcsine x. So sines and their inverse functions. Now I didn't go over the other ones like secant x and cosecant x, but they're pretty self-explanatory, and you can just search them up by yourself. Along with the double angle identity, all those other ones, I'm sure you guys can just search that up by yourself. But anyway, we can do yeah, this is good. By the way, if you think I am forgetting about roots, remember I'm not forgetting about roots, because like I said, we want to move away from this to this. Sorry, this. We just want it to be fractions in the exponents. Same thing. We want fractions. Fractions. We don't want roots. We don't want division. We want fractions. Okay? It makes solving problems so much easier when you think about it like this. So, if you know all these functions and all their inverses, you can solve any algebra problem now for physics, and math should not be the issue. Okay? Thank you for watching this video.